in triangle KMN. So what you do, you start by drawing a triangle and labeling KMN and seeing what you know. Now, is this triangle drawn to scale? Absolutely not. I drew it without even looking at dimensions. It's okay to draw things not to scale, right? Sometimes you might, after drawing things, change things a little bit. But according to this, K to M is 16. K to N is 11. And M to N is 6. And once I label it, I sure feel like if this is not to scale. Can you see that my 16 side and my 6 side do not sort of match up with 16 being much bigger than 6? But that's okay. Determine the measure of angle M. Well, that would be this angle right here. Is this the sine law? Obviously, it's not a right angle triangle. Can't use SOHCAHTOA. Can't use a squared plus b squared equals c squared. So if it's a non-right angle triangle, the first thing we look at is, in determining whether we use sine law or cosine law, is first we check the sine law. And the sine law, you would need to know one angle and its opposite side in order to use it. We don't know any angles, so we don't use the sine law. So then we go, should we use the cosine law? And I don't know if you remember, my instructions for when to use cosine law was when the sine law doesn't work. Well, the sine law doesn't work. This will be the cosine law. The cosine law has two forms. It has one form that had c squared equals on one side, and another form that had cos c equals on one side. They both work, and they both work in whatever situation you have. However, you would use this one when you want to find an angle, and this one when you want to find a side. So we want to find an angle. It's going to be easier with the cos c one. So we start off by going, oh, I don't have A, B, and C. The key thing, though, is whatever angle you're finding, it goes with the opposite side. So I want to find cos of M. So on my formula, the M squared is the minus part over here. This is where the 11 squared would go. Right? I'll rewrite it out here just for the visual. Right? A squared plus B squared minus C squared over 2AB. Again, you're in pre-calculus. Planning on taking grade 12 next semester, hopefully if you're in grade 11, so that you can take AP Calculus in grade 12. AP Calculus doesn't give you a formula sheet. So when we learn new formulas now, take a little bit extra time to see if you can have them mostly memorized. You still have a formula sheet in grade 11, but if you can practice memorizing your formulas already, that will help you when you get to grade 12. So what do we put in here? It doesn't matter the order of these ones. And if you have a graphing calculator, this is great to use the fraction button. If you don't know how to use the fraction button and you have a graphing calculator, you can come see me. The older graphing calculators, if you have a TI-83, don't allow for it. I get 57 over 64. Some of you, that'll come up as a decimal. Mine right now is coming up. I just changed it back to decimal. 0.890625. So we get cos M equals positive point. According to your CAST rule, cos is positive. So it's either in quadrant 1 or quadrant 4, not in 2 and 3. And based on the situation, because we have an actual triangle, can you see that quadrant 4 will not be possible? You can't have an angle bigger than 270 degrees in a triangle. So this one really brings it back to a grade 10 question. If you want to find M, it will be the same as the reference angle. We just have to do the cos inverse of that on your calculator. Use your answer button to make sure that you're using all of the decimal places. Oh, I didn't even write it. I've got a 0. 0, 0, perfect. Didn't even notice that was missing. And we get angle M is 27 degrees. Taken to the nearest degree? Beautiful. So I like to go, when I figure something out, label it in my triangle. I know that angle M is 27 degrees. Logic question. In your opinion, using mathematical logic, do you think smiley face angle is bigger or sad face angle is bigger? Without doing any math, we're going to try to figure this, well, without doing any complicated math, we're going to try to figure this out. What do you think? Happy is bigger, sad is bigger? Obviously, it's not drawn to scale. Okay? Why do you think the happy is bigger? You're just taking a guess. Perfect. Sad? Why do you think sad is bigger? You guessed as well. Somebody guessed. Wouldn't it have to be happy because you're a better guesser? No. No? Okay. If you thought of it to scale, okay? So I'm going to draw 27 as best as that. Oh, is that best as I can to scale? And then 6 would be, wow, that would be longer there. Okay? And then I have that. If you drew it more to scale, you're right. It looks like happy is bigger. And you are right. The happy one is bigger. So that's a great way to think about it if it was drawn to scale. Then, something that may make sense to you after we've drawn it to scale. Does it make sense that the longest side would go with the biggest angle? Because the wider the angle gets, that stretches out the other side. The narrower an angle gets, it would force the other side to be small. Think about a right angle triangle, which is always the longest side. Hypotenuse, which is always the biggest angle, the 90-degree angle. So this will be the biggest angle. The sad face actually will be even smaller than 27, because the 27 is opposite of the 11, and 6 is smaller than 11, so the sad face one will be the smallest angle. Which, now, we've sort of put a culture on angles that angles are happier when they're bigger. I don't know. Is that true? Right? If you get too big, I don't know, the words sound the other way, right? What do you call an angle bigger than 90 degrees? That's the 180. Obtuse. Would you rather be called acute or obtuse? Now I'm starting to think, well, maybe I should have put the sad face on the big angle and the happy face on the small one. Because it sounds nicer to be called cute than obtuse. I don't know. Maybe angles don't have feelings. This is still an unknown mathematical question. Do angles have feelings? Now we're getting all this. Okay, sorry. Oh man. Can't wait to hear the comments on this one. Part B. we've got triangle Stu. So again, I label Stu. No wonder Stu has feelings. ST is 16. SU is 20. And TU is 6. Determine the measure of angle T to the nearest degree. Again, can we use the sine law? Can we use cos SOHCAHTOA? No, it's not right angle. So then we go to our sine law. We don't have an angle on an opposite side. So then we go that was a good attempt at cleaning up the blood. How did it work? How are you doing? Fine. So we want to find angle T. Again, cosine law, those two are going to go together. So cos of T equals, over here, I'm going to put the minus 20 squared. The other numbers don't matter. 16 squared plus 6 squared minus 2 times 16 times 6. Go to my fraction button on my calculator. Alpha y equals fraction. 16 squared plus 6 squared minus 20 squared over 2 times 16 times 6. Enter. Negative, oh, I want to change it to a decimal because that's, I guess I can leave it as a fraction. Fraction's kind of nice. But if you got it as a decimal, if you're trying this on your own, your number would have shown up as negative 0.5625. And most calculators will give you the decimal. So I'll write that as the decimal on here. Cos of T equals negative 0.5625. According to our cast rule, if cos is negative, it's not in 1 and not in 4. It has to be in quadrants 2 and 3. However, quadrant 3 will be an issue. If I draw this triangle in quadrant 2, this fraction was 9 over 16. I could label that the adjacent side is 9 and the hypotenuse is 16. If I wanted to find my reference angle, oh, and I labeled it a little bit poorly. I shouldn't have used theta r. What should I have used? T with a little r. That's the angle I'm trying to find. And if I have that right angle triangle, I can go back to grade 10 math and I can say, I can find this angle because cos of my reference angle is positive 9 over 16, or positive 0.5625. If I go to my calculator, I can go second cos inverse 9 divided by 16, and I get 55.77. Then my angle T, can you see that all the way to here would be 180? If I wanted to find angle T, I would have to do 180 minus my reference angle. And I get 124.2. Does it ask for the nearest degree? Wrong page. Yes, the nearest degree. 124 degrees. If I go back to my triangle, I could have labeled in here 124 degrees. Obviously, 124 will be the biggest angle in that triangle, because the rest have to add up to 180. Is it opposite the biggest side? Yes. Okay. Now, I want to show you something that is kind of nice, but also kind of nice, but kind of creates some problems later on. So ideally, okay, in this situation, I want you to think about the cast rule, because this is good practice. I want you to think about what quadrant it's in. I want you to find the reference angle, and I want you to use the reference angle to find t. But I want to show you, and this only works for cos in quadrant 2, that if you had done cos inverse of the negative value, negative 0.5625, it does give us 124 directly. The problem is then, if this was a question you also had to find the answer in quadrant 3, you would not be able to find the answer in quadrant 3. So this is the reason that I would say we should always think of our cast rule and find our reference angle. Because if you had a reference angle, can you see that you could find the answer in quadrant 3 by doing 180 plus your reference angle easily? If you just found 124 directly, you wouldn't be able to easily find the answer in quadrant 3. So it's good practice to do a method that will help you later on. However, right, if you really understand what's going on, then I feel free to do cos inverse of negative and get the answer right away, right? The beauty about mathematics is if you fully understand what's happening, there's lots of shortcuts that you can use, which are great. But if you're using a shortcut without understanding, I guarantee you will make mistakes you don't want to make in mathematics. Because you're going to try to use a shortcut when you're not allowed, or you're not going to know how to do something when the shortcut doesn't work, so we have problems. So it's good to see both, but it's good to make sure that you know the main method first. Okay, questions that you can do for practice on this one are 5 and 7. Okay, we are going to